Aliens? NASA, renowned for its groundbreaking discoveries, has recently revealed that this new planet is not only intriguing due to its size and location, but also because it exhibits lights that appear to be artificial. Are we on the verge of uncovering secrets that could change our understanding of the universe? Could this discovery mean there is life on other planets? Join us as we explore NASA's intriguing findings and uncover the truth about these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with a mission to explore some of the most intriguing objects in our solar system. Dawn was uniquely equipped with 3 ion engines, allowing it to undertake an unprecedented journey. Dawn's journey began with a 14-month survey of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data revealing Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn embarked on the second and perhaps most exciting part of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and set course for Ceres, a feat that traditional chemical propulsion would have found challenging. These engines provided a continuous, gentle thrust, allowing Dawn to travel vast distances efficiently and enter into a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most intriguing due to its unique characteristics. As Dawn approached Ceres, scientists eagerly awaited the first detailed images of this mysterious world. They found bright spots scattered across its surface, most notably in a large crater now known as a crater. These bright spots sparked immediate interest and speculation within the scientific community. Before Dawn's mission, the best image we had of Ceres was a fuzzy, low-resolution picture taken by the Hubble Space Telescope. Scientists knew so little about this dwarf planet, and the prospect of finally getting a close-up view was thrilling. What secrets would Ceres reveal? What new discoveries awaited? The mission promised to enhance our understanding of the solar system's formation and the role of water in shaping planetary bodies. The bright spots on Ceres are unlike anything observed on other asteroids. They appear to be composed of highly reflective material, possibly salts left behind by sublimated water. This finding hinted at the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquid instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about the nature of Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands out from other celestial bodies in the asteroid belt because of its size, mass, unique composition, and potential for water and ice. Unlike typical rocky asteroids, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015. This moment marked a significant milestone in the mission as Dawn prepared to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew nearer, the images of Ceres grew increasingly detailed, offering glimpses of a world that had previously been shrouded in mystery. The first images revealed a surface dotted with craters indicative of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts alike. Among these features were mysterious bright spots that boldly stood out against the darker rocky terrain. As the images continued to improve in resolution, the scientific community buzzed with theories about the nature of these bright spots. Were they ice patches reflecting sunlight? Or could they be something even more exotic? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity, but rather a cluster of several distinct spots. This discovery only deepened the mystery. The hypothesis that these were deposits of salts left behind by sublimating water gained traction, suggesting that Ceres had, or still has, some form of geological activity capable of bringing water or briny liquids to the surface, where they quickly evaporate, leaving bright reflective residues. These findings challenged existing notions about Ceres, painting a picture of a more dynamic and complex world than previously imagined. The presence of such features hinted at the possibility of subsurface water or briny pockets, which could have profound implications for our understanding of the potential for life in our solar system. What makes Ceres different from other planets? Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids in the belt, which are primarily composed of rocks and metals, Ceres stands out due to its unique composition. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, which give it a distinct, less dense structure compared to its neighbors. This composition suggests that Ceres has a significant amount of water. The surface layer is rocky but porous, with ice and other volatiles trapped within. This icy characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that might involve a mixture of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more fascinating aspects of its makeup. The dwarf planet is believed to have a differentiated interior consisting of a muddy mantle and a core. The mantle is thought to be rich in water ice, accounting for approximately 50% of Ceres' total volume. This mantle, likely a mix of rock and brine, surrounds a core that could be composed of a denser material, possibly silicates. The presence of such a significant amount of water ice suggests that Ceres may have once harbored liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres implies that the dwarf planet may have formed in a colder part of the solar system and migrated inward. The presence of ammonia can lower the freezing point of water, supporting the existence of subsurface brines. These insights into Ceres' composition and history not only enhance our understanding of this intriguing dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, particularly when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the extreme cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes function by allowing water packed with dissolved salts to reach the surface. When this salty water makes contact with the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to gas. This leaves behind bright reflective salt deposits, forming the mysterious bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater named Decatur, known as Spot 5. This area has garnered significant attention due to its high reflectivity and periodic hazes observed by the Dawn spacecraft. These hazes are believed to be caused by the sublimation of water, which suggests that cryovolcanic activity might still be ongoing or occurred relatively recently. In addition to Spot 5, Ceres hosts several other bright spots, each with its own unique characteristics. These spots are not limited to a single area but are scattered across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and active nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The surface of Ceres is dotted with a variety of craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an old surface that has been subject to numerous impacts over billions of years. Others are more well-preserved, with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is fewer than initially expected. This discrepancy hints at geological processes that might be renewing the surface and erasing evidence of older impacts. One theory is that Ceres' icy composition allows for a form of cryovolcanic resurfacing, where subsurface materials periodically well up and cover old features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and possibly still is, dynamically evolving. Further evidence of geological activity on Ceres comes from the observation of fractures, grooves, and troughs crisscrossing its surface. These features indicate that the crust of Ceres has experienced significant stress and deformation. Some of the fractures appear relatively young, possibly only a few 100 million years old, suggesting that the crust is still active to some extent. Grooves and troughs on Ceres likely formed as the crust was stretched and pulled apart, while rows of mountains and compressional ridges indicate areas where the crust was pushed together. These contrasting features provide a clear record of the internal forces shaping Ceres. Understanding these stresses and their origins helps scientists piece together the geological history of Ceres, revealing a world where internal and external forces interplay to create a diverse and active landscape. The unique geological activity observed on Ceres, from its cryovolcanoes to its stress-induced fractures, highlights the complexity of this dwarf planet. These findings enhance our understanding of Ceres itself and offer valuable insights into the processes that might be occurring on other icy bodies in our solar system. But that's not the only interesting thing that can be found on the planet's surface. One of the most striking features on Ceres is Ahana Mons, a solitary mountain that rises about 4 kilometers above the surrounding terrain. This unique geological structure stands out due to its steep slopes and relatively smooth, bright surface. Unlike other mountainous features on Ceres, Ahana Mons is not associated with any impact basin or apparent tectonic activity, making its origin a subject of considerable interest and study. Scientists hypothesize that Ahana Mons may be a cryovolcano, a type of volcano that erupts volatiles such as water rather than molten rock. The smooth, bright surface of Ahana suggests that it is relatively young, with an estimated age of just a few 100 million years. This youth implies that cryovolcanic activity could still be occurring on Ceres, reshaping its surface. One leading theory for the formation of Ahana Mons involves the propagation of seismic waves. These waves might have been generated by a massive impact on the opposite side of Ceres. When seismic waves travel through a planetary body, they can focus at a point directly opposite the impact site, known as the antipode. This focus can cause localized heating and fracturing of the crust, potentially leading to the eruption of subsurface materials. Ahana Mons on Ceres is a unique cryovolcanic feature, but similar mountains can be found on other icy bodies in the solar system, showcasing diverse geological processes. For instance, Olympus Mons on Mars, the tallest volcano in the solar system, rises 22 kilometers above the surrounding plains and is a shield volcano formed by repeated lava flows. Although much larger, it shares some characteristics with Ahana Mons in terms of isolated formation and steep slopes. On Jupiter's moon Europa, there are also signs of cryovolcanism, with features such as Thera and the macula. These regions exhibit evidence of ice flows and potential cryovolcanic activity, suggesting that Europa, like Ceres, might have subsurface oceans that occasionally breach the surface. Another example is Enceladus, a moon of Saturn, which has ice geysers erupting from its south polar region, driven by subsurface water interacting with the moon's rocky core. There is another fascinating aspect of Ceres, the presence of water ice within its polar craters. These craters, located near the poles, are in a state of perpetual darkness due to Ceres' minimal axial tilt of just 4 degrees. Certain regions within these craters never receive direct sunlight, creating cold traps where temperatures are low enough to preserve water ice for extended periods. The discovery of water ice in these dark craters is significant for several reasons. It provides direct evidence that water, a key ingredient for life as we know it, exists on Ceres. This ice could be remnants from the early solar system, offering a glimpse into the primordial conditions that existed when Ceres formed. The stable cold environments within these craters make them ideal for the long-term preservation of ice, much like similar features found on our moon. On the moon, permanently shadowed craters near the poles also harbor water ice. These lunar ice deposits are considered valuable resources for future human exploration, providing potential sources of water for life support and fuel production.